Hello and welcome back to the Rice Robotics Club Robo-Tutorial. In this video, we'll be completing our second to last subassembly. It's going to be between our base hub and our base motor, which is shown here. It'll properly position this base motor inside of the base hub. So we'll go back to our Onshape document, create a new assembly from the file select, and we'll need to insert the parts that we need for this assembly. We need the base hub. The only other part we need is the base motor, which again is an assembly. So navigate to Assemblies in the dialog box, select Motor, and finalize the selection. You'll notice this base motor shaft is no longer there because we removed it in the previous step, which is actually good because if it still had the shaft, we'd have to remove it, or else we'd have two motor shafts in our final assembly. So this is exactly what we expect and what we want. So to start, remember that this motor is not actually fully defined with itself. We'll need to apply a group mate to make sure that the different parts of the motor aren't allowed to move around with respect to one another. So select group mate from the toolbar. Select all of these parts and finalize that group mate. And now all parts move together, which is what we want. Now, as you could probably guess, we're going to apply a fastened mate. Select Fasten Mate from the toolbar. You're going to fasten the bottom of the base hub to the origin. So select the bottom of this face, make sure that it's at the center of this circular face. And then select the origin to fasten the two together. This looks like what we want for this assembly, so click the green check mark to confirm. And then exit the mate dialog. And now it's time for another slider mate, just like we did earlier with the link to subassembly. But in this case, we're going to have to make a few more changes to the mate connectors to get this base motor properly positioned inside of this holder in the base hub. So select the slider mate from the toolbar. Our first mate connector will be on the bottom face of this motor. Click to confirm, and then the other face will be at the center of this bottom groove where the DC motor will be held in the base hub. So it's not oriented correctly, but that's because we need to mess with the mate connectors. So for now, we'll confirm the mate, exit the mate dialog. Let's see which direction these two are allowed to slide. So they're allowed to slide in the Z direction, but we actually want them to slide along this groove in the Y direction, okay? So just like before, that means we need to edit the mate connectors that make up this slider mate. So hit the drop down of the slider mate we've just created. This first mate connector is the one that I selected first when creating the mate, which is fixed to the DC motor. So we're going to go edit this motor. Now if we look at the assembly that we already have here, we want it to be oriented in this way. So we need to make sure that the primary axis, which as a reminder is the direction in which the two bodies are allowed to slide around with respect to one another, it needs to be parallel to this direction, okay? Now remember, since this mate connector is fixed to this motor, we need to select some reference on the motor to realign this mate connector. So click Realign in the mate dialog, and then we're going to select Primary Axis Entity. And then for this purpose, this edge is fine. It will properly realign the primary axis so that now, it may be difficult to see, but now it's pointed along the length of the motor rather than perpendicular to this surface, which is correct. The mate still looks pretty messed up, but that's because we need to edit the other mate connector. Confirm these changes to this mate connector, and then edit this second mate connector. And for me, this mate connector is fixed to the base hub in this groove. And so we need to realign its primary axis. And we'll use this edge of the groove to properly realign it. And now that actually looks almost correct, okay? The sliding direction is almost correct, but we do need to rotate it around so that the motor is on top of the groove rather than on the bottom. And we can do that by reorienting secondary axis. You can hit this several times to just rotate the two bodies about each other. But in this case, this is the correct orientation, but there's still a problem here. So you can see that the motor, instead of sitting on these supports, is actually sitting on the groove itself and phasing inside of the base hub as a result. And this is because one of the mate connectors is on the bottom of the motor, and the other mate connector is at the bottom of this groove. And whenever you put them at the same position, this is what you get. The two parts end up phasing into one another. So in order to fix this problem, we need to shift the mate connector that's fixed to the base hub, and we need to shift it up by a certain amount so that the motor will actually be sitting on these supports. So for now, we're going to confirm these changes, and we need to find what distance we need to shift this motor upward so that instead of sitting on this groove surface, it's sitting on the support surface. So to do this, we'll use our measure tool, select the face of the groove, and then the face we want the motor to sit on. Open the measure tool, and you'll see that the parallel distance between these two planar surfaces is 9.5 millimeters, which means we need to shift the mate connector that's fixed to the base hub 9.5 millimeters upward in order for the motor to be sitting in the correct position for our assembly. So find which of these mate connectors is fixed to the base hub. For me, it's the second one. Edit it. Now look at the directions of its axes here. So this green axis is the y-axis, and we actually want to shift it 9.5 millimeters upward, which in this case is the negative y direction. Okay, so in the mate dialog, we're going to select move, and in the y position, we need to shift negative 9.5 millimeters, which I believe should shift it upward, and now this motor is sitting like it realistically will in our final constructed robot arm. Click the green check mark. And now this slider mate is finally complete. If you click it and you drag it, it will slide in the direction that we expect. And you can see it's no longer phasing into the base hub in this position. Okay, now that this slider mate is complete, we just need to constrain this motor's translation along this axis to fully define this assembly. And in this case, we'll just be adding a planar mate to the back of this motor and the front of these support points just to make sure that the motor is always sitting resting in the position where those faces are always planar. So select the planar mate from the toolbar. Select the back face of the motor. Select the front face of either of these support points to make the two coplanar. Solve the mates to make sure everything looks correct. And that does look good. Click the green check mark to confirm the mate. And now this subassembly is complete. If we can drag this motor, it won't move, neither will the base hub. There's one more quick change that we need to make because there's not currently a method. Whenever we CAD'd this base hub, we didn't give any method for this motor to actually be bolted to the base hub. So we're going to do, it's called editing in context. So you can edit, for example, this base hub in the context of the assembly, which allows you to reference not only like sketches and things that are in the part studio of the base hub, but you can also reference the base motor. This is a really powerful tool, and in this case, we're going to use it to basically project these holes in the motor into our base hub and add cutouts for the purpose of connecting the motor to the base hub. Okay, so to edit in context, we're going to right-click this base hub, and then we're going to find the Edit in Context option in the menu. Select it, and now we've opened the base hub Part Studio. You can see we've navigated inside of our parts folder in the file select, but now you can see the silhouette of this motor at all times. So this is going to be a very valuable tool for basically referencing other parts as we're adding features to other parts in an assembly. So I'm going to create a new sketch. It's going to be on the support platform here. Reorient the view. So now we're going to select the Use tool from the sketch toolbar, and we're going to project both of these holes onto our base hub. Okay. And now you'll see as we've created the sketch, and as soon as we've referenced components in this assembly, it has this arrow And that means that this sketch was added to this part in context, and we're referencing something from outside the Part Studio to define this sketch. Just be aware that's what this arrow means. So these circles are incomplete, so we're going to select both circles, convert them to construction, and now we're going to add our own circles that are centered at the same position. So draw a center point circle with its center here, and then we need to make sure it has the same diameter as that construction circle we've just drawn. So you're going to add an equal relation between the circle we have just drawn and the construction circle. Okay. And now we're just going to use well, I guess we'll just draw another center point circle down here, go through the exact same process, apply an equal relation to those two circles, and now this is fully defined. Now we just need to extrude this downward into the base hub, removing material to add a hole so that we can mount the motor to this base hub. So we're removing material, and we're going to go to a depth of 10 millimeters. Click the green check mark to confirm the feature. We're going to rename it. Great. And now we've edited this part in context. We're going to hit Go to Assembly to return to the assembly. Takes us back to our subassembly here. And if you look through this motor, you can see that we've added holes in the base hub that align perfectly with those motor holes. And now this subassembly is complete. Only one more subassembly to go, and it'll be between our base plate and our servos. And I'll see you in the next video to complete the next step.